What's the difference between the byte object and strings in Python? Well, it's changed a little bit since Python 2, and it's something that a lot of folks struggle with, especially when they're getting data from the web or reading binary files. Learn more on this week's MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. This week I want to talk a little bit about the bytes object in Python and how it's different than a string and how we can use encode and decode to go back and forth between these. It's really not that hard once you understand the concept, but it's confusing if you've never seen it before, and it's something that I see a lot of folks struggle with. So we're going to get a real-world example here. I'm gone to the University of Wyoming radio sound archive here and pulled a sounding for the Denver area. I'm going to go ahead and copy that URL, but you could do this with any URL. And this is a pretty common thing I see when people are web scraping that they hit and are a little bit stumped by. So I'm going to use urllib. I'm going to import the request object. Going to save that URL to a variable called URL. And now we're going to go get the contents of that web page. So contents equal request.url open our URL. And I'm going to call the .read method on that because it's a file-like object until we actually read through it with .read. So we run that. It's gone and got those contents. If we look at them, we see all of the HTML that makes up that web page. Nothing too out of the ordinary here. But notice before the quote enclosing all this content, there's a B. That is your first hint that this isn't a string, but indeed this contains bytes. If we were to look at the type of contents, if you haven't seen this before, type tells you what variable type things are. So in this case, it's bytes. So let's look at the contents again. And the first bit of it here is HTML enclosed in less than greater than symbols. This is an HTML tag. We can do lots of things to contents that we can do to strings. We could call .split to split it on any white space characters. We could call strip to remove those characters. We could do most of those string method looking things. But what if I index into it like a string? So here we would expect to get a less than symbol. That's this first character right here, or the 0th character. But when we run it, we see I get the number 60, which is really confusing because if it's a string and I'm indexing into it, I expect to get one thing back, not 2 digits. Well, herein lies the problem. The computer is storing these characters as binary somehow, right? The computer fundamentally must store things in a binary format. We have agreed upon a convention using Unicode, or before that, the ASCII table, of how we're going to represent characters in the ASCII table days using numbers from, that you could hold in an 8-bit machine. So let's look at an ASCII table. This is ASCIItable.com. We have the decimal, hex, octal, and then the character and a description. If the hex and the octal don't mean much to you, that's okay. But let's go down here and find decimal 60. Decimal 60 is the less than symbol. So when we type the less than symbol, we're storing the 8-bit integer 60 to represent that. So we've all agreed on this table. And really that was pretty good for a long time. But some of the higher numbers, different folks were using in different ways, and that's why Unicode has come about, to try to unify all of the text tables that we have. But it also extends that table, so we can have different languages. some languages like Chinese that have many, many characters beyond what we were going to have in the normal 8 bits that we were using originally are accommodated by things like Unicode. So we have to agree on the format that we're going to use. Otherwise, it's meaningless. I can encode it using my special encoder wheel, and if you don't have the same encoder wheel, you're not going to get the same output. So let's go back into Python. We can do something like, you said, well, maybe I can just make it a string, right? So I'm going to call str on contents. Okay, well, that didn't quite do what we expected either. We now see that the B has become part of the string, and then we're escaping the single quote. So if I call the 0th index thing on that, we have B, not the less than symbol. So that's not what we were looking to do either. What we need to do is decode. So decode goes from the binary representation, decodes it using whatever table we give it, and returns a string back. So if I call contents.decode, if we look at the help here, we see that the default encoding is UTF-8, but you can specify anything. You could specify one of the ISO numbers or any of the other tables that are out there. We'll stick with UTF-8 for now. So if I call contents.decode, we see the B is gone, and now it looks more like a normal string. So I'm going to store this in a variable called contents decoded. If we look at the type of contents decoded, we see that it's a string. Contents decoded, the 0th element, is now our less than symbol. So we now have a string that works exactly like we would expect a string to work. Encode, on the other hand, goes the other way. If you have a string and you want to encode it into some binary encoding. In fact, some folks argue that this should be the recommended practice, that we take our input as binary, we decode it, we work with it as strings in Python, and then we re-encode it to some standard like a UTF-8 on the output. And that's really not a bad idea. But to show you some ways that this can go wrong, let's do a simple example. So I'm going to create a variable called myData, and it's going to be the string temperature equals 20. Then I'm going to use the \N, and here I can put a human readable description of the Unicode character that I'm wanting instead of trying to remember what the exact Unicode number is for the degree symbol, which I never do. And then C. So if we look at my data, it says temperature equals 20 degree symbol C. Perfect. So what's the type of my data? You should be able to predict this. Right, it's a string. So now we can call encode. So I'm going to say encoded equals my data dot encode. If we look at encoded, now we see it's a byte string, and we have these escaped characters here, and this is what represents the degree symbol in binary using the UTF-8 table. That's a very important caveat. So now if I take my encoded and I call .decode, well, that works beautifully because we're encoding and decoding using UTF-8. But remember I said we can use any of these special tables that we want. So I'm going to use the ISO 8859 table -11, which I believe is the Thai character table. Most of these tables will have the standard alphabet, the English alphabet first, and those won't change. But the higher number characters, such as degree symbol, will change. And so now we see we no longer have 20 degrees C, but everything works happily. So if you've opened up a file and you see all kinds of weird characters displayed, you probably opened a binary file and you're trying to read it in something like UTF-8, which is not what it was encoded in. So you have to know how the file was encoded. Even if it's not text encoded in the binary, it could be a bunch of packed float values or a bunch of packed integers. So this is where getting used to working with binary data is becoming important with these larger and larger data sets that we have now. There are some tools like NetCDF that make it a lot easier, but when you run into problems, it's handy to know these things. Also, working with strings is always hard. And this is something that I'm sure you'll run into as you work with parsing strings or pulling data down from the web. I hope that you found this useful, and I'll see you on next week's MetPy Monday.